The more that you progress in GTNH, you're going to start setting up a whole bunch of these automation setups. Now, in the earlier game, you're going to probably have stuff that looks like this, where you have a bunch of machines dedicated to one type of product. For example, these here making light fuel, and you have another one dedicated to a different product, in this case, this one making heavy fuel. Then you'll probably have something where you have dedicated chemical reactors for each one of your sulfuric inputs. Now, by no means is this a bad setup. This will run perfectly. You'll get all of your light fuel, you'll get your heavy fuel, you can make your diesel, whatever you want to do. However, if you look at it, you're going to see that there are a few, let's say, inefficiencies in this setup. For example, it's not actually a 2-to-1 ratio in terms of the distillation process if you were to make diesel. It's actually a little bit more like a 1.6 to 1. So in this case, these distilleries are actually going to run less often than this one. So that might not sound like the most important thing, but it means that technically, while you have 3 distilleries built, you actually only need like 2.2 or something like that. Now, generally, again, not a huge issue, this will work. However, as you start scaling things up, you'll realize that those small inefficiencies really start to add up. Another issue that might not be super apparent at the moment is, let's say that you want to eventually switch these distilleries to a different setup. Maybe you want to distill refinery gas, maybe you want to get some naphtha. Well, you're going to have to go in, swap out the circuits, and have a whole different input coming in. And that's not necessarily the most fun thing to do. You already have the machines, you already have the automation set up, but it doesn't exactly translate well if you want to do a different set of inputs in the same machine. Once again, not the most problematic thing when it comes to early game. However, when you start going through a whole bunch of tiers, adding a whole bunch of new recipes, you might see yourself redoing a whole bunch of these setups. Now you might think to yourself, what can I do about this? Well, the general solution is to use applied energistics. This is basically just a really good way of centralizing all of your inputs for machines, as well as giving them multiple patterns so they can do more than one recipe. So in this case, this distillery is only making light fuel because we only have these pipes that are going to be pushing oil in. However, if we start using applied energistics patterns, we can actually start quantizing our recipes in a way that they will be able to do more than just a single recipe per machine. Using applied energistics patterns, we can tell it that a certain amount of one item will make a certain amount of another item. And through doing that, let's say I want to go ahead and I have a recipe in here for the electrum dust and another one for indium gallium phosphate dust. And through using that, I can go ahead and tell it, hey, craft me some electrum dust. We'll see it throws it all in the mixer, starts making things, we get our electrum. This is great, gives us basically exactly what we're looking for. However, there is one small downside. If I say, well, now I also want to craft my indium gallium phosphate, it's going to go ahead and just throw all of those inputs right in the same mixer. Now with this recipe, it's not the biggest issue. However, you'll start noticing that there are a lot of recipes that are going to conflict in the same machine. So let's say that we have a recipe here that used a different thing, let's say something that reacts with silver. Then instead of getting what we actually want, the silver is going to mix with the other recipe, and we're going to get a third completely different and essentially not the right dust that we're trying to make. Now, that might seem like we just have a whole problem right here and the whole thing is useless. However, what we can actually do is go ahead and tell this interface, hey, turn on blocking mode. What that's going to do is allow us to tell it to craft our indium gallium phosphate, but instead of simply shoving all of the items right in, what it's actually going to do is wait until the inputs are empty and then shove all of the items in. What this allows us to do is essentially just skip that whole part where they could be mixing with each other and creating a different recipe, and it's going to keep them nice and separate so we get exactly what we want out of our machines. However, not every single recipe you're going to be doing is just item based. For example, looking at the mixer again, I have a recipe set up to make charcoal. And in this case, we're actually going to be using the charcoal mixer recipe that uses sulfuric acid and sugar. Now, the issue here is that we need a way for applied energistics to input the sulfuric acid as well as the sugar, and for it to do that, we actually need to turn the sulfuric acid into an item. So in this case, I'm just using flasks, which are a nice way to transfer specific amounts of fluid. However, you can't just put an interface on a machine and shove the flask in. You're going to need something to turn it into a fluid again. So in this setup, I just have a simple chest, pulls out of the chest, and then here I whitelist all of the flasks, ignoring NBT data, and then here I blacklist all of the flasks. So what that's going to do is basically put all of the items in here and all of the flasks in here, which will empty, and then you see with this fluid conduit, it'll then put all of the fluids in here. So if I go ahead and I just queue up one of those, we will see that I actually was very dumb and I set the face of the machine to where the inputs are, but if I swap it over there, we will see sulfuric acid and sugar go in perfectly, start mixing, start making our recipe. However, you'll see that if we go back to our previous idea of the blocking mode, there's a bit of a small issue. Let's say I do put blocking mode on, and there are items in here. If I were to go ahead and queue up another one of these, it's actually just going to go ahead and shove it all in here. And the reason for that is the interface isn't touching the machine anymore. So the blocking mode isn't really going to work because the inventory that it's touching gets all of its items taken out right away. This is where things get a little complex, and we need to start looking at the idea of how to make a blocking mode that can apply to more than one inventory. So our interface isn't actually going to be touching what we need the blocking mode to apply to, so we're going to need to essentially extrapolate the idea of a blocking mode and apply it within this part of the logistics. Now, if we want to apply the idea of blocking mode to a fluid inventory, we're going to have to do a little bit of shenanigans. Now, this might look a little confusing, but essentially all I'm doing is taking the idea of blocking mode and transferring it into essentially just low-level logic. The idea being we have an inventory, in this case our fluid input hatch on our quote-unquote LCR. This has a detector which is going to signal to our setup whether it has items, or in this case whether it has fluids or not. This tank here is just to empty the flasks. Then we have this chest buffer which is on the interface, and you will see that if I take the interface off, we actually have a shutter module here. Now the idea of this whole setup right here is we have this chest buffer with an item detector, machine controller, and a shutter. So what it'll do is it keeps the shutter open until it gets an item. Then the item detector will trigger. It's going to swap this gate. That is going to stop supplying a signal to the machine controller, which is going to close the shutter and stop any further input. So if we set this to blocking mode, and we throw this in here, basically it'll try to shove its first item in here, then it will see the inventory is full, the blocking mode will work, it won't put anything else in. This is going to trigger the latch, swap the latch here, stop giving the signal, which is going to close the shutter, as well as, if we look at this signal here, it is going to enable this, which will pull the items out of the chest buffer when it closes the shutter. Basically, airlock type thing, takes an item in, stops input, pushes the item out. Then to reset the latch, we have a NOT gate on a normal fluid detector feeding into a pulse former. And the idea here is basically this will get fluids in it. You'll see at the moment it doesn't have any, but it'll get a fluid. The machine will run, it'll use up the fluid. Once it runs out, this NOT gate will actually, in this case, go ahead and enable, as it is right here. And because of how the Pulse former works when this gets a signal, sends a pulse, resets the latch, tells it to send another recipe in. Essentially what we're doing is taking the blocking mode here, and we are telling it to apply that blocking mode idea to this inventory that not only does it not touch, but actually doesn't even accept items. So if I were to go ahead, go in here, and then craft myself up one fluid detector, and then another fluid detector, you'll see my pattern is basically just a fake flask to fluid detector. The idea here is it will apply to any LCR recipe, but I just set up this fake thing. You'll see the first one looks like it's working fine, but the second one is actually not going to be able to input. And that is because that shutter has enabled. And even though this chest buffer is empty, because of the shutter, AE will not be able to push any more recipes in. However, if we look here, we will see that this tank in my Wayla actually has a bunch of fluids in it. So does this one. So if I go ahead and pull out my plunger, we can pretend that this is the machine doing the recipe, using up all the inputs. Then, once it starts getting to the end, we will see that the latch is in this position. This is the position that blocks inputs and pulls the items out of the chest buffer. But if I were to go ahead and take out the last bit of fluid, we will see first this NOT gate will enable, send a pulse here, which will pulse the latch, switch it over, and it will allow another recipe in. AE will push it in, and it'll end up in this hatch. So, if you look at my Wayla, you should be able to see that when I click it, it gets empty, and then just like that, another recipe gets put in. By no means is this any type of perfect setup, but I will say that it does have a few things going for it. Generally, this is about as compact as you're going to get it using any type of logic gates, and for the most part, it's not really going to get any simpler than this. Now, the downside there is something that might not be immediately apparent, but when you start thinking about machines, and especially machines like the LCR, you're going to realize that they actually do very easily hit one-tick recipes. Well, that might not seem like the biggest problem normally, and when you're just shoving a lot of inputs into them using dedicated setups, it's actually by no means really an issue. When you're doing something like this that actually swaps recipes, if you don't swap the recipe within that one tick of the recipe that was previous before it, you're going to end up with the machine actually turning itself off in between recipes. And while that might not, again, seem like the worst thing, depending on how big your patterns are, if you're running one-tick recipes with about one flask per recipe, you could end up with things where the machine will turn off for 1 to 2 seconds and it will only turn on for maybe 3 to 4. So looking at like some pretty big efficiency losses there with the machine simply just not running. We're going to have to get a little bit more creative than this. Now, I intentionally started with the Project Red logic gates because I've actually gone down this path and I found that while you can get really close to that one tick swap, it's actually, in my opinion, impossible to do it with Project Red. And that comes down to a few contributing factors. Basically, if you need to move everything within one tick, you have only one spot for any delay, and that delay can only be one tick. So up here we have the item translocator, we have this tank, we have this cover, we have these covers. All of these are things that are going to introduce small amounts of lag. You know, it does take one tick for it to move that stack of items with the translocator. It's going to take one tick for that flask to empty in the tank. In this case, I have a pump here between the tank and the hatch, and that is going to take one tick to pull all of the fluids. Then we're looking at least a tick on all of the logic, and at that point we're already at like 5, 6, 7 ticks, which by no means is ideal. Now you might think that Open Computers would be a really good solution here, but Open Computers itself actually does have a lot of delays. When you're searching a lot of inventories trying to move a lot of things at the same time, it's going to get a little tricky. You'll see here we only have one input hatch, but a lot of recipes that are in the LCR are actually going to use quite a lot of inputs. If we look at hog, for example, that's a solid 5 fluids right there and a program circuit. Now for open computers to read all of those inventories, move all of those fluids, it's not really going to be able to do that with the logic all within the same tick. So this is where I'm going to start getting a little bit more in depth with it, and we're going to actually swap over to using Steve's Factory Manager. Now this might seem, oh, that's actually way worse. If you look at any of the triggers, you see 1-second intervals. Not ideal. However, you will see that through a couple shenanigans we're going to pull, it's actually possible to not only have all of the logic, but all of the item movement occur within the same tick. So what that means is if we have a fluid detector here, the machine will empty, it will run that last recipe, and during the single tick that it is running that last recipe, SFM will be able to do all of the logic and all of the movements to fill the machine up again and avoid it turning off anywhere in between. Now a quick recap of the reason that any of this actually matters. Generally, the way that people go about setting up processing setups for many things, especially when it comes to stuff like the LCR and most multi-blocks, they're going to do things where, let's say this LCR here, well this one's going to make the high octane gasoline. This one here, well this one's going to do polyethylene. Maybe this one here, this does PTFE here. And this one, well maybe this is the one that has some like AE item recipes. Now, don't get me wrong, this will work, you know, you can push all your inputs, but generally you're not going to be making things in ratios thus that, you know, you make exactly as much of this as you do of this, same amount as this, same as this. So you're going to have times where maybe you're crafting a whole bunch of AE items. You're making a bunch of, let's say, charged Certus crystals, but you're actually full on your fuel source, you're full on polyethylene, and maybe you're also full on PTFE. So you're going to have 3 out of your 4 LCRs here just completely turned off, and you're going to have this 4th LCR being the only one that's running. Now, in our setup here, we're actually able to, instead of dedicating single recipes per machine or single processing chains per machine, we have an unlimited amount of recipes that can be pushed into all of our machines. So, say you're running low on polyethylene, you know, AE will push a recipe in, our SFM will handle it, and it will push it to all 8 machines. Then maybe PTFE comes up and it pushes it to all 8 machines. The idea here is as long as you're crafting something, it's going to utilize all of your processing power, instead of having dedicated parts of your setups being dedicated to certain recipes, not always running all of the time, and essentially losing out on speed. Now I hope this helped explain at least some of the introduction, the benefits, as well as the issues that come with trying to put all of your recipes in all of your machines. And I would like to be able to explain a super easy solution to tell you exactly how to do it, but it is not easy at all. The SFM shenanigans you have to do to get that to work alone are quite complex. There's a lot of very, very strange little mechanics that you're going to have to learn, and generally it's not something that's as easy as, you know, hey, put a machine on, put an interface on it, maybe set it to blocking mode. Even this here with all of these logic gates pales in comparison to the shit that we are going to have to do to make this work. So, hopefully in the next video I'm going to have a little bit more on some of the techniques that you can actually use. We have some things such as the redstone triggers here. These are actually going to be able to have our SFM run more than once a second, as well as run exactly when we need it to, instead of waiting for that interval. Some other things we're going to be doing is a little bit of SFM based counting and variable storage, and that's going to help us do things such as in this setup you'll see that we have a tank with a pump between the tank and the hatch, and if you remember when I was talking about tick delay, we already have one guaranteed tick loss on the fluid detector cover. So if we were to use a pump here, we would actually end up with another tick loss, and that would essentially make the whole setup impossible. So we're going to use a little bit of counting and variable storage to tell SFM to use these tanks here as secondary inventories that are paired to specific hatches. Hopefully that doesn't sound too complicated, but there should be a lot of very interesting stuff that will be coming up in the next part of this series.